Hello my dear students, welcome back to my class. In the previous videos, we have discussed some practical session videos. We have seen how to execute some programs on formatted input-output functions and unformatted input-output functions. Hope you have practiced those programs. In today's video, we will discuss about type conversion. So what actually this type conversion is, the different types of type conversion and how to use type conversion, let us see. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. If you have already subscribed, you can subscribe from some other devices also, like the videos and share the videos. What is type conversion? The name itself tells you type conversion. It is the process of converting one type of data into another type. So it says converting a data type of one variable to another data type, which is type conversion. But why we have to do this type conversion? So when we have complex expression in our program, it is the duty of the compiler to evaluate that expression very smoothly. But when that expression consists of variables, constants of multiple data types, it will be very difficult for the compiler to evaluate. So then it makes use of this type conversion. So what it will do? It will convert one type of data into another type. So why this conversion requires? Why this conversion requires? Why we have to convert one type of data into another type? Because the data that what we use will be stored under different memory allocation. So let us talk about the fundamental data types. So we have the character data type, we have integer data type, we have float data type and double data type. And all the data types that what we have is associated with its different memory allocation and it varies from machine to machine. So let me talk with respect to 16-bit machine. For integer, character, float, double, the storage capacity is like this. We've already discussed about these data types and its storage capacity in the previous videos. Please do check out that. So character takes 1 byte, integer 2 bytes, float 4 bytes, double 8 bytes. So it is in the increasing order. The storage capacity is in the increasing order. So I can say this is the data type with lowest storage and this is the data type with highest storage. So when the compiler has to convert the expression, it has to convert based on this memory allocation. So if I have a data with 2 bytes representation and one more data with 1 byte representation, then it's quite difficult to do the evaluation. So it has to be converted, it should be compatible. It means to say I have to convert that 1 byte of data to 2 bytes. So both the data should be of 2 bytes. So it is from low to high. The data type has to be promoted to the highest storage, not to the lowest storage. So like this, we have to do the conversion. The compiler has to do the conversion. In order to do that conversion, it makes use of 2 types. So which are those 2 types of conversion? So here we have 2 types of conversion. One is implicit conversion and the other one is explicit conversion. So we have 2 types of conversion, implicit type conversion and explicit type conversion. So let us talk about these 2 types of conversion in detail now. Implicit type conversion. The name itself tells you implicit type conversion. The conversion is taken place implicitly. So here automatic conversion is done. So who is going to do this automatic conversion? So automatic conversion in the sense it is done by the compiler. So the compiler is going to take care of the conversion. Hence, there is no user intervention. So user or the programmer need not bother about how to convert this one type of data into another data type. So let us see a small example now, like how this compiler is going to do this implicit type conversion. So for example, I have a character data type CH assigned with a single character A and an integer variable, say I say int b equal to 10. Then I say int x equal to ch plus b. So now here ch is of character type and b is of integer type. When I say the ch, which is of character type, it requires 1 byte storage, and b, which is of integer type, it requires 2 bytes of storage. And when we want to perform this arithmetic operation, what the compiler will do, it converts this low data type to high data type. Means it gets converted to integer. So character is 1 byte and integer is 2 bytes. So what the compiler will do, it converts this low data type to high data type so that it can perform the operation very smoothly. So here what happens, the ch, which has the value a in the sense the letter a, the ASCII value for a is 97. It gets converted to integer. So it is 97, and in b what do we have? We have 10. So it is 97 plus 10, which is 107 stored in x. So in x we get the value 107. So this is how the implicit conversion took place by the compiler. The compiler automatically converts this character type to integer type and the operation is performed. Let us see one more example. So I have an integer variable a, which is 10. Then let me take a float variable, say b. Then what I'll do, I'll assign the value of a to b. Actually, a is of integer type and b is of float type. And when I say store the integer value into the float variable, then what the compiler will do? It will do an automatic conversion. It will convert this integer data to float. This is an implicit conversion. So we have a, which is having 10, and b, which is getting the value of a. So this integer data has to be converted to the float and then it has to be stored here. So it will be stored in the form of float 10.000. So when I say print the value of b, say printf b equal to percentage f, print the value of b, my output will be 10.000. So integer data is converted to float. This is implicit conversion, which is taken care by the compiler itself. This is what implicit conversion. Explicit type conversion. The name itself tells you explicit type conversion. It is the process of converting one type of data to another type explicitly. Means the programmer has to forcibly convert one type of data to another type. It is also called as typecasting. So when I say type conversion, we usually say it is implicit conversion. And we have seen the implicit conversion, which is from low data type to high data type. The low data type gets promoted to high data type. So we have seen character data type got promoted to integer, or integer data type got promoted to float. So here we have to make the expression compatible. If it is integer, then one more data type of float, then integer to be promoted to float, and both should be float, and then the operation will be done. So it is from low data type to high data type, implicit conversion called as type conversion. But talking about the explicit conversion, we call it as typecasting. So here typecasting, it says there is no automatic conversion. The user or the programmer has to forcibly convert one type of data to another type. So we have a proper syntax for that. It says you have to mention the data type within brackets. So we have studied this while listing the operators. We call it as typecasting. So the data type has to be mentioned and the variable that has to be converted. Say for example, a small example, I say I need to convert a float data. So that I need to convert the result to the float. My value will be in integer. Say for example, I have a variable which is of integer type. I say convert this x to float and then do the next operation. So let us see some example. So let me take a small example. I have an integer variable and I have a float variable assigned with a value say 10.23, something like this. Then what I'll do, I'll assign the value of b to a. So if I simply write this and try to print the value of a, I may not get a valid output. I may get some junk output, but sometimes the turbo software may support this expression. Sometimes you may get the output. You may get, see here you have 10.23. Let me represent this with memory block. You have a which is nothing, which has nothing, and you have b which has the value initialized 10.23. Now this statement is saying to store the value of b to a. The copy of b to a. B is 10.23 which is a float. I can't fit this float value to integer because float has occupied 4 bytes and integer takes 2 bytes. Storing this 4 bytes of data to integer is quite difficult. So this implicit conversion can't be done. Sometimes the turbo software may do the implicit conversion. It takes only the whole part and stores. But some machine may not do that. You may get some junk value. For every execution, you get some junk value. So what we have to do? We have to do the explicit conversion. So what we can do? I say a equal to convert this float value which is in b to int. So b I have 10.23. Convert this to integer. So here when I say brackets takes the first priority according to the operator precedence rule, and typecasting has also the first priority. So typecasting has the highest priority, brackets has the highest priority. So it converts this value b to integer type and then it stores to a. So b is having 10.23, it gets converted to integer, means it becomes 10 and that will be stored in a. So a gets 10. This is one example. Explicit conversion. See here the syntax we have followed, data type followed with a variable. Convert this value which I have in this variable to integer and then store it to a. Let us see one more example now. I have written the complete program. You can have all the ash includes, you can have clear screen, you can have getch, all those things. So I have 3 variables, a with the value 10, b with the value 3, and you have the variable result to store the resultant. Then I say result equal to a divided by b. So what is 10 divided by 3? We get some result in fractional oriented. So 10 divided by 3 means it is something like 3.333, something like that. But here the result is of integer type. When I do the division operation of integer type, so a is also integer, b is also integer, integer division, obviously I get the result in integer format only. So it is just 3 that what I am going to get, that gets stored in RES. So in RES my answer will be 3. So when I say printf, print the result equal to %d, print the value of RES, I am going to get 3. But this is not the accurate answer. So when we want to have accurate answer, then we have to do the explicit conversion. So what we can do here is, we will simply change the data type of this. So what I'll do, I'll say float res. Then I will do the explicit conversion here. I say result equal to, let me convert the variable a to float type. Float of a divided by b. Then change the format specifier. Result is of float type, print res. So let us see what happens here. So here, as usual, a equal to 10, b equal to 3. I have declared result here. So result is the variable which is of float type. Make sure that you declare that variable of float type. Then I do the explicit conversion. So according to the operator precedence, brackets gets evaluated first and typecasting has the highest priority. So what I'll do here, it says convert this variable a, only this variable a, to float type. So it becomes 10.000. So it is 10.00. So divided by b, b means 3. 10.00 divided by 3, my answer is 3.33. Store that in res. So it is, and automatically implicit conversion takes place here. B also gets converted to float. It becomes 3.00. 10.00 divided by 3.00. My answer is 3.33 that gets stored in res. Print the result, the format specifier f for float. Print the value in res, it is 3.33. This is how the explicit conversion takes place. So you can just execute all these programs and check out the output. Any doubts, you can just post your doubts in the comment box. And please execute all these programs and just put your answers, post your answers in the comment box. Any doubts, you can just post it in the comment box. I can clear it. So that's all for today's video. See you in the next video. Till then, take care. Bye-bye.